All right, so today we're going to be looking at lesson 15-2. We're going to be looking at trapezoids. So we're continuing our discussion on different types of quadrilaterals, and this is a trapezoid where you are going to have exactly one pair of parallel sides. That is what the definition for a trapezoid would be. So if you have no sides that are parallel, or if you have two pairs of sides that are parallel, that is not going to be a trapezoid. It has to be exactly one pair. Your parallel sides are going to be called your bases, and then the sides that are not parallel are called your legs. So I'm going to go ahead and draw my trapezoid, and then I'm going to label my bases and my legs before I come back to the base angles. So here is one example of a trapezoid. These two sides are parallel, and so they are my bases. The other two sides are my legs. They are not parallel. Now looking at the base angles. They are going to be pairs of consecutive angles, and they have to include the bases. So if you look at one of your bases, I'll look at the bottom one. On either side of that base is an angle. Those two angles are base angles. However, we have another base at the top. On either side, there are two angles that create base angle pair. And so those are another pair of base angles. So when you have a trapezoid, you actually end up having two pairs of base angles. Then it wants us to label the vertices, T-R-A-P. It does not matter where you start with T. I'm going to choose the bottom left here. You just have to make sure that you either go in a clockwise direction or in a counterclockwise direction with your labeling. R is not going to be able to be across from T. It has to be either going clockwise or counterclockwise. So I'm going to go counterclockwise this time. So T, R, A, and then P. And so there is your trapezoid. So one thing to think about, do the bases always have to be horizontal when you're dealing with a trapezoid? And no, they don't. It could be turned any direction. So the bases do not have to be horizontal. So now we're going to look at the median of a trapezoid. It's similar to the mid-segment that we looked at in the previous lesson. Your median is going to be the segment that has endpoints at the midpoint of your two legs. So I'm going to look at this figure that they have drawn for us. M is the midpoint of side FE, which means FM is congruent to EM. Likewise, N is congruent, it's the midpoint, and makes GN congruent to HN. However, FM does not have to be congruent to GN. Those don't have to be congruent. It's just saying that M and N are midpoints of their respective sides. So the trapezoid median theorem. The median of a trapezoid is parallel to the bases. So this is our median. It is parallel to the bases, and its length is the average of the length of the bases. So what that means, the median is MN. The two bases are F, G, and E, H. And if you add those and divide by 2, that gives you the median. Another way to write that is to double the median. So 2 times MN equals FG plus EH. Either way, you'll get the same result. So it doesn't matter which one of those you use. So we are going to take this figure and try and use the triangle mid-segment theorem to help us justify the trapezoid median theorem. So we're not going to do a formal proof here. We're just going to kind of work through a little bit of how you would go about a formal proof. So the first thing they want us to do is to draw one of the diagonals in our trapezoid. So I'm going to do the one from E to G. And it says to label that intersection with the median as X. So if we are using the triangle mid-segment theorem, we know that XN has to be parallel to EH. And we know that MX has to be parallel to FG. And that's because we have two different triangles here, where XN is the mid-segment of that blue triangle, and then MX is the mid-segment of the green triangle. And so if XN is parallel to EH, that means that MN is parallel to EH, which is what we were trying to prove here. So we can say MN is parallel to EH. Likewise, if XM is parallel to FG, that means that MN is parallel to FG. So MN is parallel to FG, which is what we were trying to prove here. Technically, all of those should have segment markings above them. Then we're going to prove the second part. Using the triangle mid-segment theorem again, I'm going to erase my marking so that I can draw on it. We know that XN is half of the length of EH, and I can write that as XN is half of EH. And we know that MX is half of FG. Then we also know MX plus XN creates the segment MN by the segment addition postulate. So MN is going to equal MX plus XN. And we know from here that XN is 1/2 EH. And we know from here that MX is 1/2 FG. And if you see, they both have a 1/2 that we can factor out to give us FG plus EH times 1/2 is going to equal MN. And that's what they were trying to get you to prove there. So that would be how you would go about trying to prove it, those basic steps. kind of outlines that proof. We're not going to go into more detail there. They just wanted to get you to try and explain how it would work. So now we're going to look over here, connect to language. The British used the term trapezium, and that's with a quadrilateral that has exactly one pair of parallel sides. And they use the term trapezoid for a quadrilateral with no parallel sides. So they actually use different terms for these figures. In English, what we use, trapezoid, has one pair of parallel sides, and a trapezium has no pairs of parallel sides. We have them switched. And the book says that they also drive on a different side of the road. So if you go to a different country, they may use a different term and not use trapezoid. But here in America, we use trapezoid for a figure that has exactly one pair of sides that are parallel. So we are going to be using that figure that we were just looking at for number 3. So given this trapezoid, and I'm going to redraw it so that I don't have to flip back and forth. They tell us that angle F or GFE measures 42 degrees. And they want us to find the measure of angle NME. These lines here, all three of these are parallel. And so this angle and this angle are called corresponding angles. And when you have parallel lines, your corresponding angles are congruent. So the measure of angle NME would be 42 degrees. Then they ask us about the measure of angle MEH, which is here. These two angles are not congruent. They are called same side interior angles. And so if this one is 42 degrees, this one is going to be supplementary to that, which is going to be 138 degrees. For part B, it asks you to look at the side lengths. So they tell you that FG is 4x plus 4, and that EH is x plus 5, and that MN is 22. So the first thing that we need to do is to set up an equation. You can set up either one that we looked at just a minute ago. There are two different ways you can set it up. I'm going to choose to do double the median equals the two bases. So 2 times the median equals the two bases. You could say 22 equals 1/2 of 4x plus 4 plus x plus 5, if you would rather do it that way. You'll get the same thing. So now we're going to multiply and combine like terms. Subtract 9 and divide by 5 to get that x equals 7. And that's all it asks for. Write an equation and solve for x. So x is 7 there. For part C, it is not using these same pieces of information. What it is telling you is new, different, not related to part B. It wants you to find FG. We don't know what it is. It tells you MN is 19 and EH is 12. So again, my median is 19. 2 times 19 equals the two bases, FG and EH. So 2 times 19 is 38. If you subtract 12, FG is going to equal 26. There's another way that you can think through this, and some of you may like it, some of you may not. If this is 12, you have to add 7 to get to the 19. You're going to add the same amount to get to the top one because these are the same distance away. So add 12, from 12 you add 7 to get 19, add another 7 and you get to the 26. So it doesn't work when you have your expressions like we did to start with, but on ones where it's the numbers, you could do it that way. Okay, so now let's look at number 4. What property or postulate allowed you to draw the auxiliary line in item 2? So that was the line where we drew from E to G and labeled it as an X. And that property is through any 2 points, there is exactly one straight line that you can draw. So through any 2 points, there's exactly one straight line. That's what allowed us to draw that line. Anytime you have 2 points, you can always draw a line between them. So now let's look. How does a trapezoid differ from a kite? Well, there are a couple of ways that they differ. One of them, a trapezoid has 2 parallel bases. It has a pair of parallel sides. And a kite does not have any pairs of parallel sides. Another way that they differ, we looked at yesterday, the kite has 2 sets of sides that are congruent. And a trapezoid does not have any such requirement. It does not have to have any sides that are congruent. There are other differences that you may be able to come up with. There are some similarities. One of the similarities would be they both have 4 sides. But it asks how are they different. So those are some of the easier ways to tell how they're different. Number 6 says, can a trapezoid have bases that are congruent? No, it can't. And the reason, if I have my parallel sides that are congruent, these are parallel and congruent, and I connect those, that is a rectangle, which is not a trapezoid, because that creates these being parallel. But it doesn't have to be a rectangle. It could create something like this, which is a parallelogram. A rectangle is a type of parallelogram. We'll get into that later in activity 15. But can a trapezoid have bases that are congruent? No, because then it forces the other pair of sides to also be parallel. And so that is why it will not work. Now we're going to look at an isosceles trapezoid. So that's going to be a trapezoid that has congruent legs. Remember, isosceles means that you have 2 sides that are the same length. So an isosceles trapezoid has 2 sides that are the same length, and those have to be the legs that are congruent. So now we're going to look at this triangle, and yes, I realize it's a triangle and we're looking at trapezoids, but we're going to get to a trapezoid in just a moment. So we have a triangle, and they tell us it's isosceles. They tell us that AB is congruent or equal to CB, and that AD is equal to CE. The first thing they ask about is angle A being congruent. So angle A is a base angle of our triangle. The other base angle is angle C. So angle A is congruent to angle C, and the reasoning is that base angles of isosceles triangles are congruent. That's back from when we looked at isosceles triangles. So now, how do we know that this smaller triangle, BDE, is an isosceles triangle? And the reasoning there, we know that side AB is composed of segments AD and DB. And we also know that side CB is composed of segments CE and EB. Then, using substitution, we know AB and CB are the same thing. So we could replace one with the other. We also know AD and CE are the same. And so we could replace one with the other, meaning that DB and EB have to be equal. So that forces these sides to be congruent. So by substitution, you'd end up getting that those sides are congruent, and that's why the triangle is isosceles. DB is going to have to equal EB, so triangle BDE is isosceles. Now looking at part C. AC is going to be parallel to DE. And the reasoning there. We know that angle A here and angle BDE have to be congruent. Because they are corresponding angles. And if your corresponding angles are congruent, your lines have to be parallel. Then it asks about the quadrilateral ADEC. How do we know it's isosceles and how do we know it's a trapezoid? So isosceles, we know that AD is congruent to CE. That's what they gave us at the beginning. We also know that DE is parallel to AC. We just talked about that. And that is the definition of an isosceles trapezoid. So, quadrilateral ADEC has one pair of parallel sides, which was DE parallel to AC, and the other side, the other pair of sides, are congruent, which was AD congruent to CE. And so that's how we know that it is isosceles and a trapezoid. So now it asks about angle ADE congruent to angle what? So angle ADE is right here. It is supplementary to angle A. I'm going to write that. Angle ADE and angle A equal 180. Because they are same side interior angles. I'm going to draw that again so that you can see it a little more clearly. This angle and that angle are supplementary because we have parallel lines. Likewise, this angle and this angle are supplementary. So angle DEC and angle C are supplementary, which means that this angle and this angle are congruent. So angle DEC is congruent to angle ADE. And the reason they're supplementary to the same angle. So A and C are congruent to each other, and they're both supplementary to A and C. And so supplements of congruent angles have to be congruent. Which leads us to the next part, which says to complete the theorem. The base angles of an isosceles trapezoid are congruent. So you have base angles A and C. Those are congruent. And then base angles here, and here are congruent. And so at the top of the next page, the base angles of an isosceles trapezoid are congruent. And that's always going to be the case. Only with an isosceles trapezoid. If it's just a regular old trapezoid, that doesn't mean that your base angles have to be congruent. So now we're going to look at number 8. The first thing that we need to do is to plot it. And you have grid paper over on the right, so go ahead and plot out your points. So there's your quadrilateral. And so the first thing that we want to do is to show that it's a trapezoid. So the definition of a trapezoid is that we have exactly one pair of parallel sides. So we need to find the slope of all of the sides. So I'm going to start with the two that appear to be parallel. OL and CD. And if you count the slope rise over run, up 1 over 3, your slope is 1/3. If you look at the slope of CD, you go up 2 and over 6, which reduces to 1/3, which means OL is parallel to CD. Now we need to look at the slope of the other two sides. The slope of CO is 2 over 1, which is just 2. The slope of LD, up 1 and to the left 2, would be negative 1/2, and those are not the same. So that means that CO is not parallel to LD. And so that shows that it's a trapezoid. Since the quadrilateral COLD has exactly one pair of parallel sides, it's a trapezoid. Now we want to show its isosceles. So the two sides that are going to be congruent, making it an isosceles figure, are these two that I just drew over in red. And so we are going to use Pythagorean theorem. A squared plus B squared equals C squared. And so I'm going to create my right triangle here. That side length is 1, that side length is 2, and that's my C. So 1 squared plus 2 squared equals C squared. 1 plus 4 equals C squared. 5 equals C squared. And so your hypotenuse length is square root of 5. So the length of CO is the square root of 5. The other one is LD. And if you look, 1 and 2, which is what we just did, and so our hypotenuse is also going to be square root of 5. So the length of LD is the square root of 5, which means that CO equals LD. And there you have that it's isosceles. The next part, they want you to find the length of the diagonals. So you have two diagonals here. One of them is C to L. And if you draw the triangle, 1, 2, 3, 4, 1, 2, 3, and you use Pythagorean theorem, you end up getting that your hypotenuse is 5. So the length of CL is 5. Then the other diagonal is from O to D. And that one is a horizontal line. And so you can just count. giving you that the length of OD is 5. And so based on that, they say complete the theorem. The diagonals of an isosceles trapezoid are congruent. So that's what we think might be true. Now number 9 is actually going to be proving it. But we're not going to go through a full formal proof. It says write the key steps for the proof. So we don't need to do the whole proof. We're just going to write out some of the parts that we would need. So they tell you you have a trapezoid, and they tell you that CO is congruent to ER. That means that we have an isosceles trapezoid, which means that we have to have congruent base angles. So this angle is congruent and that angle is congruent, but those aren't the ones that we're going to want to use. We're going to want to use the angles at these two corners. Angle COR congruent to angle ERO. And the reasoning is by the base angle congruence of isosceles trapezoid. Since we have an isosceles trapezoid, we know we have base angles that are congruent. That's what we looked at the very top of page 211, part F. The base angles of an isosceles trapezoid are congruent. Now, if you look, I'm going to trace two triangles. Triangle ERO and triangle COR. Do you see that they have a side that is overlapping over here at OR? Since it is overlapping, that means that it has to be congruent to both of them. So OR is congruent to OR by reflexive property. And then if you look at the red markings that I have, we have side, angle, side. Side, angle, side. So our triangles are congruent. Triangle COR is congruent to triangle ERO by side, angle, side. And then that means that all of our corresponding parts of our triangles have to be congruent. So by C, P, C, T, C, CR has to be congruent to EO. And those are your diagonals in your figure. They're the longest sides of your triangles. And so, since our triangles are congruent, the corresponding parts are congruent. And that's what CPCTC represents. Corresponding parts of congruent triangles are congruent. So now let's look at number 10. They give us a quadrilateral, PLAN, and they tell us it's an isosceles trapezoid. And they want us to use those properties to find the missing parts. So they tell you that LPN is congruent to another angle. It is going to be congruent to its base angle over on the right side, which is angle PLA. Those are base angles and they have to be congruent because we have an isosceles trapezoid. If we know that the measure of PLA is 70 degrees, that means that the angle measure of LPN is also going to be 70 degrees. Then PNA is going to be supplementary to this angle that we just had as 70 degrees. So that means 180 minus 70 leaves you with 110 for the measure of angle PNA. Part C gives you side lengths. They tell you AP and NL. And those are your diagonals. Your diagonals are congruent because it is an isosceles trapezoid. So that means that AP has to equal NL. So X has to equal 3X minus 8. If you subtract 3 from x, you get negative 2x equals negative 8. And when you divide, you get that x equals 4. And that's all that they were looking for with part C. So now let's look at the practice questions. For number 11, they tell you that UV is a median. What that means, U is the midpoint of side QT, and V is the midpoint of side RS. So if UT is 3 over here, that means that QU is also 3. I know it doesn't look like they are congruent, but if it's the median, it has to go to the midpoint. On the right side, if RV is 4, that means that VS is also 4, because V has to be the midpoint of those sides. Then, UV is your median. So UV is half of the sum of the two bases. So UV is half of 26, which means that UV equals 13. So now looking at number 12. They tell us that EF is a median of an isosceles trapezoid. So, if it's a median, that means that these two segments are congruent because E is the midpoint. That also means that F is the midpoint and these two segments are congruent. But since it is an isosceles trapezoid, all 4 of these are actually congruent because side AD is congruent to side BC. So we can set up an equation and say 6y minus 1 equals 2y plus 3. So subtract 2y and you get 4y minus 1 equals 3. So 4y equals 4, which means y equals 1. And then if you want to go ahead and plug y in, that means 2 times 1 plus 3, AE would be 5, which means ED would be 5, which means BF would be 5, which means FC would be 5. And if you plug in 1 for your y, you do get 5. Looking at the x values, our median is 2x. It is going to equal 1/2 of 8x minus 43 plus 10. Or you could say 2 times your median equals your 2 bases. Either equation is going to work. I'm going to choose the bottom one just so that I don't have to take half of 43, but either way you'll get the correct answer. So 2 times 2x is 4x equals 8x minus 33. Subtract 8x to get negative 4x equals negative 33. And then when you divide by negative 4, you end up with a positive 8.25. So x is 8.25. Then we need to plug those in to find the length of AB and EF. So 8 times 8.25 minus 43 is going to leave you with 23 for AB. And then 2 times 8.25 is going to give you 16.5. And if you check, your top base is 23, your bottom base is 10. And if you take half of that, it should equal 16.5 because that's your median. And that does work. So you can kind of check and make sure that you plugged in and solved your equation correctly. So hopefully that helps you a little bit with understanding how trapezoids work. You got to remember some of your properties of your figures in order to work through these properly.